Hi everyone, welcome to AI Exact channel. This is Akash Gangwar and today we'll be studying Quadratic lecture 3. So this is the last lecture of Quadratic and we'll be studying common roots and few other concepts in this lecture. So let us start with common roots, and it's quite obvious that if we are studying common roots then there are two possible cases. Either one root is common between two quadratic equations and either two roots are common. So let's look at the case 1 where both roots are actually common. Now, let's say we have this equation ax1 square plus b1x plus c1 equals to 0. Now, if both roots are common, then it's pretty obvious that since the quadratic equation has two roots only and both are common, then the other equation would be exactly same as the first equation, right? But how are they different now? So let's say the other equation is a2x square plus b2x plus c2 equals to 0. Now this has roots alpha beta and this also has alpha beta. So both the equations should be similar. So how can they be different? So in this manner they can be different. Let's say a2 equals to 2a1, b2 equals to 2b1 and c2 equals to 2c1. So basically we have an additional factor 2. So this is nothing but this particular equation is nothing but 2 times a1x square plus b1x plus c1. And now since this is equals to 0, so 2 gets cancelled out. So they actually are both the same equations, but because of this particular factor 2, they look different, right? So what should be the condition based on which we can say that two roots are actually equal, two roots are actually common? So in that case, we have equation a1x square plus b1x plus c1 equals to 0 and a2x square plus b2x plus c2 equals to 0. Now the second equation is nothing but the product of the first equation and a common factor which is being multiplied to all the coefficients. So basically that gives us the condition a1 by a2 equals to b1 by b2 equals to c1 by c2 equals to some value k. If the ratio of all the coefficients is exactly same and maybe some constant k, in that case we can clearly say that both the roots are common and basically both the equations are identical. Now let us look at the second condition, second case where one root is common. Now this one is a little trickier. So before going into this particular expression, we will start with the basics of 9th and 10th class where we studied elimination method while solving two equations and two variables. Now these are our two quadratic equations, a1x square plus b1x plus c1 equals to 0, a2x square plus b2x plus c2 equals to 0, and we have assumed that alpha is a common root. Alpha is one single common root. Now, when alpha is a common root, we can clearly write a1 alpha square plus b1 alpha plus c1 equals to 0 and a2 alpha square plus b2 alpha plus c2 equals to 0. Now, we have to eliminate. So basically, we have to find out the value of alpha square and alpha. Okay. So basically, we have to find out just like we used to find out x and y in case we have been given two equations and two variables in x and y. Similarly, we'll be finding out alpha square and alpha. We'll be treating alpha square as one variable and alpha is other variable. So let's try to find out alpha square for now. For that, what I'll be doing, I'll be multiplying the first equation with a2. So that would become a2 a1 alpha square plus a2 b1 alpha plus a2 c1 equals to 0, and I'll be multiplying a1 in the second equation. So that would give me a1 a2 alpha square plus a1 b2 alpha plus a1 c2 equals to 0. Now subtracting, this is first, this is second, subtracting second from 1. So that would give me, this gets cancelled out, and that would give me alpha times a2b1 minus a1b2 plus a2c1 minus a1c2 equals to 0. So this would eventually become, so this would eventually become alpha equals to a1c2 minus a2c1 divided by a2b1 minus a1b2. Now similarly you can find out the value of alpha square by eliminating these. In that case, what we'll be doing, we'll be multiplying b2 in the first equation, and in this equation we'll be multiplying b1. So after that we can subtract and we'll find out the value. So why are we studying that? This is the basic method in which we can find out alpha and alpha square. But we don't really have to do this in every single question of one single common root. We have to just remember this condition, and there's a trick to remember this condition. So let's look at this one. So what we'll be doing is we'll be trying to write this entire expression with the help of these two equations. So let's say we have to write down the denominator of alpha square. In that case, we'll write alpha square divided by. So we'll hide this one, and we'll do the cross multiplication just like we open a determinant for coefficients. So b1 c2 minus b2 c1, b1 c2 minus b2 c1. Now, if I want to find out for minus alpha, you have to write, remember that this is minus alpha. Just like we open up determinant first with plus sign, then with minus sign, and then with plus sign. Similarly, over here, you have to remember it. So first is alpha square, basically this one. The second one is with minus sign, minus alpha, and third one is with one only. Okay. So in this case, again, we'll be hiding this one, and then we'll be doing the cross multiplication. So that would give me a1 c2 minus a2 c1. You can also remember it like this. When you have hidden this one, you can write a determinant like this, and you have to open up this determinant over here. So this would give the exact same result. And similarly, third one, for that we'll be hiding this one, and we'll be using this determinant a1 b2 minus a2 b1. Now if you see that alpha equals to, if I compare both of them, alpha equals to a1 c2 minus a2 c1 divided by a1 b2 minus a2 b1 with a negative sign. If you do the elimination method which we did earlier, you'll find that this is exactly the same. So this is our condition for one single common root. We derived with the basics of elimination, and with this condition, we can also find out the same values, right? So you have to remember this particular condition for finding out the condition of one root when one root is common. Okay. Now let's look at this question. A value of b for which the equations x square plus bx minus 1 equals to 0 and x square plus x plus b equals to 0 having one root in common. So we'll be using that particular condition. So let's say the common root is alpha. So I'll be writing it as alpha square plus b alpha minus 1 equals to 0 and alpha square plus alpha plus b equals to 0. Now if I try to write the condition, then alpha square divided by, so I'll hide this one and do the cross multiplication. That would give me b square plus 1 equals to minus alpha divided by, I'll hide this one and do the cross multiplication. That would be b plus 1 equals to 1 upon 1 minus b. So this is our condition. Now I'll be using this one to get the value of alpha square. Alpha square would become b square plus 1 upon 1 minus b, and similarly minus alpha would become b plus 1 divided by 1 minus b. So basically alpha equals to minus of b plus 1 divided by 1 minus b. Now I'll use both of these equations to eliminate alpha. So I'll square this one. So basically b square plus 1 divided by 1 minus b equals to b plus 1 whole square divided by 1 minus b whole square. So this square gets cancelled out. So this becomes b square plus 1 times 1 minus b equals to b square plus 1 plus 2b. So this would become b square minus b cube plus 1 minus b equals to b square plus 1 plus 2b. So this gets cancelled out, and what will be left with is b cube goes there, and this one also gets cancelled out, and plus 3b equals to 0. So basically b times b square plus 3 equals to 0. Now they have just asked for the value of b. So if in option they'll be giving you complex numbers, then also you'll have to mark that option as well. So b is either 0 or b equals to plus minus root 3 iota. So these are the values for which these two equations will be having one common root. They haven't asked for one real common root and one rational common root. They have just asked for one root in common. So in that case, we'll have to consider this value as well. Now let's look at one more question. If it is known that A, B, C are real and the quadratic equations this is nothing. Ax square plus bx plus c equals to 0 and 2x square plus 3x plus 4 equals to 0 have a common root, then A is to B is to C is equals to. Now it is given that they have one single common root, and based on the conditions which we are having, we cannot really find out three variables because we will be having just one single condition. Okay, so we cannot really find out three variables and the ratio for them, so there must have been some hidden information in this particular question. Now one thing I can clearly see, that if I try to calculate the discriminant over here, so that would basically what that discriminant would tell me, that this is less than 0. So b square 3 square minus 4 dot 2 dot 4, that is less than 0, right? So basically this equation has complex roots basically. So in case of complex roots, we know that if one root is common, then other root would also be common because they occur in pairs. So it's something of a plus iota b types, and the other root would be a minus iota b types. If this root is common, if this root is irrational, then definitely other root would also be not irrational, complex. If this root is complex, then this root would also be complex and they occur in pairs. So that is why this particular equation and this particular equation, they both are exactly same. So it's very obvious that A is to B is to C would be 2 is to 3 is to 4. So this was the trick in this question, that you have to identify that since we don't really have three equations to find out the ratios, so that is why we have to find out some hidden information based on the inside the question. Now let's look at the last topic, that is theory of equations, and that is not related to quadratic, but an extension of what we have studied earlier for quadratic. So for quadratic, it was ax square plus bx plus c equals to 0, and we knew that we derived that actually minus b by a equals to alpha plus beta, and that came out with the fact that let's divide this entire equation by a. That would give me b by ax plus c by a equals to 0, and if I write x minus alpha and x minus beta equals to 0 as the roots of this equation, and if I open it up, then I'll get to know that alpha plus beta would be minus b by k. Now you can use the similar kind of concept for higher order degree equations. So for example, we have a cubic equation, ax cube plus bx square plus cx plus d equals to 0. Now if I try to divide this by a, x cube plus b by ax square plus c by ax plus d by a equals to 0. In that case, again, I can write x minus alpha, x minus beta, x minus gamma equals to 0. Now, the interesting thing over here is if I want the coefficient of x square, in that case, I'll be taking x from here, and gamma from here. So that would give me minus gamma times x square. Similarly, one iteration would be x from here, and alpha from here. So that would be minus alpha square. Similarly, we'll be getting minus beta x square. So basically, the coefficient of x square comes out to be minus times alpha plus beta plus gamma. So over here, the coefficient is b by a. Over here, it's minus alpha plus beta plus gamma. So basically, sum of roots again comes out to be minus b by a. Now, here's the tricky part. If I want the coefficient of x, in that case x minus alpha, x minus beta, x minus gamma. In that case, what will happen? I'll take x from here, beta from here, and gamma from here. So that would give me x times gamma beta. Similarly, if I take x from here, I take beta from here, I take alpha from here. In that case, I'll be getting x times alpha beta. Similarly, I'll also be getting x times beta, no, not gamma alpha. Yes. So I can clearly see that this is alpha beta plus beta gamma plus gamma alpha. So basically product of roots, summation of roots taken two at a time. Okay. And if I compare it, then this value would become C by A. Okay. Now one thing I can generalize over here, if I have to find out the summation, then minus b by a would always be the case. Now in case of this particular thing, in that case, what I'm doing, I'm taking product product of two roots at taken two at a time. So basically product of roots taken two at a time, and that is what I am doing over here. So that would be c by a. I can see that from minus to plus over here. So it was minus b by a over here, it's plus c by a over here. And again, if I try to do that for d by a, I'll be getting minus d by a as the product of roots. So what I can generalize is, let's say we have ax4 plus bx cube plus cx square plus dx plus e equals to 0. Now in this case, sum of roots would be minus b by a. Sum of roots taken 2 at a time would be c by a. Sum of roots taken 3 at a time, that would be minus d by a. Sum of roots, product of roots basically, that would be e by a. So this plus minus goes alternatively, right? So it is valid for every equation, every degree of equation, be it 5 degree, be it 6 degree, or any n degree equation, that would be valid. So you can utilize this thing, and we have derived that as well. Okay, so this was all about theory of equations, and you can utilize these formulas whenever it's needed. So today's lecture was till here only, and we are done with the quadratic equations and theory of equations. Quadratic, as I've said earlier, it's one of the most important topic, and you'll be getting at least 2 or 3 questions from all these concepts, and it's not that easy. It's not that difficult to understand basically. And from tomorrow onwards, we'll be starting with progress and miscellaneous types of series. So let's meet tomorrow. Thanks for watching.